Today, we're diving into the world of rational numbers. You know, the ones that fill the gaps between 1 and 2.
So we have our counting numbers, we add 0, and then we add all the negatives to get integers. But what about all those gaps? Well, that's exactly where rational numbers come in.
So what are they? Basically, any number you can write down as a simple fraction.
Now, this number world has its own set of rules. Some operations play nice, and others, well, they really don't. First up, let's meet the predictable pair, addition and multiplication. They're like the well-behaved twins.
When you're adding, the order just doesn't matter. This is called the commutative property.
And what's really cool is multiplication does the exact same thing. Order doesn't matter there either.
They both share these key properties, which is what makes them so reliable and easy to work with. But what about their rebellious siblings, subtraction and division? Do they play by the same rules?
Yeah, spoiler alert, they absolutely do not. They just break all those nice patterns.
Take subtraction. If you flip the order, you get a totally different answer, so no commutativity there.
Just look at the comparison. Subtraction is missing all those handy properties that addition has.
And division? Oh, it's even more of a rule breaker. Plus, you can't ever divide by 0.
Okay, so who cares, right? Why do any of these abstract rules actually matter? Because they aren't just rules, they're actually powerful mental shortcuts that we use all the time.
The associative property lets you regroup numbers to find the easiest way to solve something.
Knowing the rules tells you where you can be flexible and where you really have to be careful.
All right, so let's wrap this up by actually seeing where these numbers live.
On the number line, they're everywhere, filling all those tiny spaces between the whole numbers.
This is what we call density. Pick any two and you can always find another one right in between them.
And you can just keep doing that over and over. Forever.
It means there's a literal infinity of numbers packed into every single tiny segment.
Which leaves us with one last, kind of mind-blowing question. If there are infinite numbers, are there still gaps?